world. It is a connected place made possible by
Alright, so the digital era has revolutionized the way we work, communicate, and store information. It's predominantly due to the emergence of cloud computing, as we know. Cloud technology offers unparalleled convenience, scalability, and accessibility, enabling businesses and individuals to store and access data remotely with ease. However, the rapid evolution and expansion of cloud computing have brought forth an unforeseen challenge. It's the management of electronic waste, commonly known as e-waste.
Glitched out, phased out, scratched up, smashed in, short-circuited. Electronic gadgets make the world go round.
So e-waste encompasses obsolete or discarded electronic devices, including servers, storage equipment, networking hardware, and other components crucial for cloud infrastructure. As the demand for cloud services skyrockets, so does the need for data centers to host and process this vast amount of information. Consequently, the life cycle of hardware within these data centers is shrinking, leading to an accelerated turnover of equipment and surge in e-waste generation. The primary contributors to the e-waste challenge in cloud computing are multifaceted. First, we got shortened hardware life cycles. In the competitive landscape of technology, the rapid pace of innovation continually renders existing hardware obsolete. What was state-of-the-art technology yesterday becomes outdated within a few years. This relentless cycle prompts frequent upgrades and replacement in data centers, exacerbating the accumulation of discarded hardware. Second, it's the increasing demand and data center expansion. The escalating demand for cloud services induces the proliferation of data centers worldwide. To meet the ever-growing data storage and processing needs, companies continually expand their infrastructure, resulting in higher turnover rates of equipment and subsequently increased e-waste output. Third, we got complexities in recycling and disposal. So e-waste poses significant challenges in recycling and proper disposal. Many electronic devices contain hazardous materials such as lead, mercury, and cadmium, necessitating specialized recycling processes to mitigate environmental risks. Improper disposal can definitely lead to environmental pollution and health hazards for communities near e-waste dump sites. Fourth is the global supply chain implication. So the complex supply chains involved in manufacturing electronic components contribute to the e-waste predicament. The extraction, the processing, and the transportation of raw materials used in hardware production often lack sustainability measures, further intensifying environmental impact.
50 million tons of e-waste every year, weighing more than all the airliners ever made.
So while the e-waste conundrum in cloud computing presents a pressing challenge, several strategies can address and mitigate its adverse effects. We got extended product life cycles, for instance, encouraging manufacturers to design hardware with longer lifespans and upgradable components can reduce the frequency of replacements, consequently curbing e-waste generation. We got circular economy approach. So implementing circular economy principle involves refurbishing, reusing, or recycling hardware components to extract maximum value before disposal, thereby reducing the environmental impact of e-waste. We got responsible disposal and recycling. So enforcing stringent regulations and promoting responsible recycling practices can ensure proper disposal of e-waste, preventing its adverse effects on the environment and public health. So we got investment in sustainable technologies, R&D initiatives, and developing eco-friendly materials, energy efficient hardware, and sustainable manufacturing processes can mitigate the environmental footprint of cloud computing infrastructure. Lastly, collaborative industry efforts. Collaboration among technology companies, policy makers, and environmental organizations is crucial in devising comprehensive strategies and frameworks to tackle the e-waste challenge collectively. So in conclusion, while cloud computing continues to reshape our digital landscape, the exponential growth of this technology brings forth the imperative need to address its environmental repercussions, particularly concerning the e-waste management. So implementing sustainable practices, embracing innovations, and fostering collective responsibility can pave the way towards a more sustainable future for cloud computing, mitigating the adverse impacts of e-waste on our environment and society.
Together, we can put this planet on the mend.